Given a function f of x, you can apply transformations to get a new function g of x. The two types of transformations we will focus on are shifting and stretching. In order to help make things concrete, we're going to look at a specific function f of x known as the triangle wave. The reason we choose this function is that it shares a lot of features with the sine and cosine functions, but its reference points are integer values, and it can be drawn using straight lines. Shifting transformations, also known as translations, come from adding or subtracting a number from either the entire function or the argument of the function. If it happens inside the argument, then it corresponds to a horizontal shift, and if it happens to the entire function, it corresponds to a vertical shift. Students often make mistakes because the horizontal transformations are opposite what we might guess. If c is a positive number, then f of x minus c shifts the graphs to the right and not to the left. To see why this happens, let's look at a chart of values for x and x minus 1. Notice that the x minus 1 values are shifted to the right. This means that when we evaluate the function, those values will also be shifted to the right. Vertical shifts don't have this behavior because you're transforming the graph after it has read the values from the function, so adding and subtracting values directly increases or decreases the final result. Horizontal and vertical stretching comes from multiplying either the entire function or the argument by some value. Just as with shifting, the horizontal stretching works opposite our intuitive guess. Again, it comes from changing the values where you're reading the values from when evaluating the function. Multiplying by 2 before evaluating the function means that you're reading values twice as far from the origin. If the value is negative, then we also reflect off the x or y axis, depending on whether the transformation is horizontal or vertical. It is important that these transformations are always performed relative to the x-axis or the y-axis, and not relative to the curve itself. This is the source of many mistakes when working on these problems. The most general transformation we can get from these has the form y equals a times f of bx minus c plus d. When graphing by transformations, the order in which the transformations are applied is the following. First, horizontal shift, then horizontal stretch, vertical stretch, and then vertical shift. The order is related to the evaluation of the expression. The reverse order for the horizontal parts matches with the pattern of things being backwards relative to our intuition. In the previous video, we graphed y equals negative 2 sine of 2x plus pi over 2 plus 2. We will now show how this looks when we graph it using transformations and see that both end up with the same result. We start with the graph of the sine function. The graph is then shifted to the left by pi over 2. Then we stretch the graph horizontally by a factor of 1/2. The negative 2 out front flips the graph vertically and then stretches it by a factor of 2. And lastly, we shift it vertically by 2 units. And we can see that this gives us the exact same result. I encourage students to use key values instead of transformations for these functions because it's easy to make mistakes on the horizontal transformations. Students often anchor the horizontal stretch to a point on the graph instead of the y-axis. I have found that students find the key values to be a little bit more straightforward and they make fewer mistakes.